Hello viewers, in today's lecture we are going to evaluate some exponential and logarithmic limits. So here we will derive the formula involving the exponential and logarithmic limits using some infinite series. So here uh, we have an infinite series for a raised to x, which is 1 plus x log a to the base e plus x square by factorial 2 log a to the base e square, and so on, right? So here we will use this infinite series to evaluate this limit, that is limit x tends to 0 a raised to x minus 1 divided by x is equal to log a to the base e, right? So this is an important limit, and we will prove this limit by using this infinite series. Now let us take this expression, that is limit x tends to 0 a raised to x minus 1 divided by x, and let us substitute this value of e raised to x, that is this series, in this expression, right? So we'll have limit x tends to 0, and here we have 1 plus x log a to the base e plus x square by factorial 2 log a to the base e square, and so on. And here we have minus 1 and divided by x, right? So here for a raised to x we have substituted this infinite series. Now see, this one and this one get cancelled, so we have limit x tends to 0, and we have x log ea plus x square by factorial 2 log ea square, and so on, right, divided by x. Now in the numerator we have x as a common factor, so this x and this x get cancelled, so we have limit x tends to 0 log ea plus x by 2 factorial log ea square plus so on, right? So here this x get cancelled with the x, which is a common factor in the numerator. So now we are left with this infinite series. Now in the first term is free from x, and the remaining terms contain x. So when x tends to 0, all these terms tends to 0, and we are left with only log of ea, right? So therefore we have proved that limit x tends to 0 a raised to x minus 1 divided by x is equal to log of a to the base e, right? Now here we have an important result if we substitute for a as e, right, where e is the exponential number, right? So if we substitute a is equal to e in this result, then we get an important limit, and the limit is limit x tends to 0. For a we have e, so we have e raised to x minus 1 divided by x is equal to log e, and here we have for a we can have e, right? And we know that log of e to the base e is 1, so this is equal to 1. So therefore limit x tends to 0, e raised to x minus 1 divided by x is equal to 1, right? Now let us take one more important logarithmic limit, and this is limit x tends to 0, log of 1 plus x to the base e divided by x is equal to 1. So in order to prove this limit, we'll make use of this infinite series, that is log of 1 plus x to the base e is equal to x minus x square by 2 plus x cubed by 3 minus x raised to 4 by 4 and so on, right? So let us prove it with the help of this series. So here we have limit x tends to 0, log of 1 plus x to the base e divided by x. Now for this term we can substitute this series, right? So here we have limit x tends to 0, and this is x minus x square by 2 plus x cubed by 3 minus x raised to 4 by 4 plus x raised to 5 by 5 and minus and so on, right? And divided by x, right? So now we have limit x tends to 0, and in the numerator we can take x common. So we have 1 minus x by 2 plus x square by 3 minus x raised to 3 by 4 plus x raised to 4 by 5 minus so on, right? And divided by x. Now this x and this x get cancelled, so we are left with limit x tends to 0, 1 minus x by 2 plus x square by 3 minus x cubed by 4 plus x raised to 4 by 5 minus so on, right? Now here we see that this is an infinite series, and all these terms get involve x, right? So the only term, the first term, is free from x, and the remaining terms contain x. Now when x tends to 0, all these terms become 0, so we are left with only 1, right? So therefore we have seen that limit x tends to 0, log of 1 plus x divided by x is equal to 1.